People say context all the time, but they often mean very different things. In MCP, context is a collection of managed resources, files, memory, state, and environment. Each type is handled differently. Context is not simply stuffing everything into a single prompt. That approach, prompt stuffing, creates token overload, privacy risk, and fragile behavior when systems scale. In MCP, context is structured and scoped. The system decides what context to expose and how to structure it so models receive only what they need, in a predictable format. MCP commonly manages 4 context types: files, document data, memory, persistent facts, state, workflow position, and environment, permissions, and runtime. We'll walk through each with examples. File context. MCP does not hand over raw directories. It provides filtered, scoped file context, the files that matter with metadata and summaries as needed. Memory captures persistent facts or preferences that should persist across sessions, user preferences, account role, or previously chosen options. MCP exposes memory as named, scoped objects that can be read or updated by the model through controlled API calls. Chat history is ephemeral. It's the recent conversation. Memory is intentional, stored, retrieved, and limited. MCP ensures memory is only used deliberately, preventing accidental leakage of past personal data. Next is state context. It tracks where a long-running workflow currently is, which step is active, and which results are already produced. MCP makes state explicit so models don't repeat or skip steps. For example, in a multi-step request, like ingest the data, then analyze and to report, MCP issues a task ID, records state after each step, and returns that state on request. This prevents duplication and race conditions. Environment context describes runtime conditions, permission scopes, API quotas, regional limits, or debug modes. MCP exposes these constraints so models can choose actions that are valid and safe in the current environment. The model does not control what context exists. The MCP server decides what to serve and when. The model asks, the server authors the facts and enforces policies. Structured context avoids token overflow, prevents accidental data leakage, and reduces hallucination risk by ensuring the model only sees curated, validated facts. Prompts tell the model what to do. Context provides the facts and state to do it with. MCP keeps these roles separate, improving clarity and safety. Bottom line, MCP makes context a managed resource. That turns messy prompts into reliable inputs and makes AI interactions predictable, safe, and auditable. In the next episode, we'll examine how MCP exposes tools and actions securely. Stay curious.